Hello guys, welcome to our next video in the playlist Google Earth Engine for land cover applications. So in today's video, we will see how we can build a classification model and how you can apply it to your multiple region of interest without repeatedly training the data. So once we will build a classification model and we will also see what are all the different classifier available like cart, KNN, the smile random forest. So everything we will see in this video, and we will build a classification model and we will apply it to other regions as well, and we'll see how does it work. So let's start by creating our region of interest. So I'm gonna create some 2-3 region of interest today. So you can select a polygon or a rectangle and you can just draw any kind of geometry. So let me delete this. So I'm gonna hover around the Mysore district. So you can just select this, draw a rectangle, and draw your multiple region of interest. So one I'm creating it here. So you can import this as a feature collection. You can have the property if you want, or else you can delete this property. So you can rename it as my ROI 1, which stands for my region of interest 1. And you can also go to some other regions as well. So I'm going north, so that you can draw one more region of interest. So let's draw it here, and you can again rename it as ROI2, which is my second region of interest, and add it a feature collection. Make it I don't need the property, so let's just save it. So I'm gonna create a one more region of interest. Just come in here so that we can have one more region of interest at here. Again, you can rename it as my region of interest 3. So import it as a feature collection and click on OK. So remember, now I have created 3 region of interest. So all of which is a feature collection. Each one have one element, that is one rectangle, or you can also call it as a polygon. And we are gonna build a classification model, and we will apply to rest of the region of interest once we build it. So now let's just get started. So we have our usual Sentinel-2 dataset. We go to Sentinel and open the Sentinel-2A surface reflectance. So available from 2017 March 28. You have the bands. You have some 12 useful bands, and remember there are scale values of 0.001 which we need to multiply in order to get the useful pixel values, or which we can interpret correctly. So we also have the image properties, which is my cloudy pixel percentage, which I want to filter. So let me copy this now, and you can import this. So now I'm going to rename it as Sentinel-2 or S2. So I'm going to create a variable called image, or you can also call it as a pre-image. So from my Sentinel-2 dataset, let's filter it down. So I'm gonna filter bounds to my region of interest ROI1. So remember, we will build first the model for the region of interest first, and then we will apply the model to the other uh, regions, that is ROI2 and 3. So I have filtered my region of interest, my Sentinel-2 dataset to my region of interest. So you can also filter it with the help of date dot filter date. So I want to have my uh, dataset for 2025. So you can just place it at 2025, and you can have the end date as 2026, since dot filter date is exclusive of the end date. So you can give 2026 so that we can have all the images which are in uh, 2025. So you can just go to the function filter date. So ee dot filter feature collection filter date. So here if you can see, the start date and end dates may have the dates numbers, and uh, the end date is exclusive, so the start date is inclusive. So just remember, the end date is exclusive here. So if you want any kind of dates to be inclusive, it should be in the start date. So additionally, I want to filter my cloud cover. So with the help of ee.filter dot less than, so less than the property which you want to filter, which is 0. Cloudy pixel percentage has to be less than 0.1. So let's just print this pre-image, click on the run, so that we can see how many image collections do we have. So we have 12 image collection. So you can just expand it here. So for the filter 2025 year, and with the cloudy pixel percentage of less than zero point 0.1, we have 12 elements. So if you can just expand this, we have 12 elements, and each of the dates is seen here, starting from 2025 January till 2025 March. So after that, we don't have a clear cloudy pixels for these regions. So it's just this much of images which we have cloud free for the year 2025. So I want to scale my values now. So I'm going to create one more variable called image, and for the pre-image, I want to uh, map a function. So remember, mapping is not the creating of for loops. So if you create a for loop, the each of the processing will take place one by one. So if you map a function, the parallel computation will takes place. So whatever your 12 images will be processed simultaneously at one time with the 12 different computation machines. So let's create a function and map it over. So I'm going to create a function which will take image as an input. So it should return the same image, but it has to be multiplied by 0.0001, which is our scale value. So you can print this to know if the function has worked or not. So let's just print the image and click on the run. So see, this is the scaled image collection. This is an unscaled image collection. So if you can just expand it, here you will see all of its properties has been lost. So here you have the dates and what is the source of the satellite image. Everything is written before scaling. But once I multiply with the value 0.001, all my properties have been lost, but the scaling has been done. So if you can just expand the bands, here you will see the band's value ranges from 0 to 6.5. So before that, if you can just expand here, so here you will see the band values are in the integer type 16. So it's not in the float type, but it is unsigned. So here you will see it's in the integer type, not in the integer type, it's in the float type, and the values ranges from 0 to 6.5. So which is the reflectance range of the images for the earth. So if from this we have understood that the scaling has worked, so now I want a single image for this image collection. So I will just add a median composite of it, and I will get clip to my region of interest 1. So now if you can just print, instead of image collection, you have a single image get computed, and you have the bands with a single image, and you have 26 bands. So remember, only the bands name which starting with the B1 until B12 is important to us. So everything this EOT, QA, 2060, so everything is not useful as of now. So I'm just gonna select the band which are starting with the letter B. So with the use of the function dot select B dot start. So this function will help you to select only the bands starting from the word B. so the letter B. So you can just expand it now. You only have 12 bands, you don't have 26 bands, starting from B1 until B12 with the scaled value from 0 to 6.5. Everything is in the float value. So now my image is ready for training, so I have to give the train. So how you can give training is that you can just come to here, and you can use any of these tools. You can add a point, you can add a polygon or shape. So remember, if you give point, your training of the data will be much better. So I will definitely suggest you to use this add a marker tool in order to train your data set. So let's just get zoomed into ROI1. So with the help of function map dot center object. So remember, you can always use control plus space button in order to automatically complete your function. So I want to center my object to ROI1. So at a zoom level of, let's say, 9. So you can just run this. So now you will see my first ROI has been zoomed in. So let me just add it to map dot add layer ROI1. So I want to style it down with the help of function dot style. So specify the parameters. I want my color, outline color, to be black and my fill color to be transparent. So the octocode for transparent 6, 2, and I want to name my layer as ROI1. Click on the run. So your function should work and you will get a new layer called ROI1. So zoomed in. So let's just adjust this zoom scale. So you can just use the inspector column. You will get the information on whatever the layer contains. So it has a point with the latitude and longitude where this was placed. So if you change the click, the latitude and longitude changes as well as the zoom level. So here you see my zoom level is 11. So I have to change my zoom level to 11 here in order to have better visualization. So you will also get the scale here in meter per pixels. So you have the lat long and information about the ROI. So now let's just start training our data set. So let me add my image in order to train this. So map dot add layer. So my image is there. I want to have my visualization. Minimum value is let's say 0 and maximum value is 0.3. So we can adjust this later. So you should also specify the bands in case you are adding multiple band layer to your image. So bands, I'm currently going for the true color composition. So with the help of 4, 3, 2. So if you don't know about the band combination, so I would recommend you to go and Google the Sentinel band combinations, and you can have it in here. So there is the first website, GIS Geography. So if you can just expand, you will have all kind of Sentinel-2 band combinations for true color composite as well as the false color composite. So with the description of each band, what is its resolution, and with the help of wavelength also, so you'll get all the details in this uh, website. So you have 432 for natural color. So if you want to have color infrared, you can have 843. So this is with the help of near infrared, red and green band. So here with the help of red, green and blue band. So if you can just scroll it down, you have multiple kind of band combinations with the 4 3 with the short wave infrared 12 8A and 4, and agriculture 11 8 2. So just scroll it down and go to this. So whatever your applications are, you can have this. So let's just coming back to our script. So we have our added our image as a true color composite with 432 band combinations with a minimum value of 0 and maximum value of zero point 0.3. So let's get this run. So you should get two layers, one for the outline and another for the true color composite. So if you want to cross check, so you can also change your base map to satellite mode with the help of function map dot set options to satellite. Click on the run. So you'll see your base map automatically changes. So you can also switch from here, but it is a good practice to use the script always. So if you can just uncheck this, so you will see our satellite image is more or less similar to our base map. So we can just check this and have the range stretched to 100%. So here you will see my range for this image ranges from 0.042 to 0.16. So that now I can change it in here from 0.042 to 0.16, so that I'll get a better contrast image of the satellite for my region of interest one. So now you see it's much more clearer and beautiful as compared to the dull base map. So now I want to have my false color composite in order to train the data. So before just going, let's get dive into the satellite image and let's see what does it contain. So just expand this. So here you see there are multiple buildings. There are some empty lands. There is some water body. There are some green cover areas. This may be some agriculture land, and you have the built-ups, roads. Everything is seen beautifully in here. So we just want to train this, and you can have a beautiful classification model. So once you train the data, so let's just get started with training the data. So I'm just gonna create some of the classes. So I'm gonna create our first class as let's say vegetation, and it should be imported as feature collection, and it should have the property this time because we are going to train the classifier with the help of this property only. So remember, this is my first class named as vegetation, and you can also change the color in order to avoid the confusions. So I have my green color for vegetation, and I'm creating one more class called build up. So it should be a feature collection, and you can have the property as class 2. So for build up, I'm using some kind of gray color. Okay, so next we will add some of the water bodies, or you can also have barren land simply, and add a feature collection. So this should be our class 4. So I'm using this morph for my build up, so it should be class 3, not 4. Okay, so let's just check with build up. Yeah, class 2. And I have my last class as water body. You can simply have water, and it should have the class name 4 and blue color for it. So now remember, my classification model has four kind of classes. One is vegetation, built up, and barren land and water. So how I decided this classes? So first I have gone through whatever we have it in the satellite image, and based on that I can classify the number of classes. So remember, you have more number of classes, you should train all the classes properly. So it's better practice to usually have more number of classes, but for this tutorial I'm only using some kind of only 4 class uh, classification model. So how you can again break down these classes is that, so for kind of vegetations, you see we have some agriculture land here. So if you can find any kind of trees, you can mark it as a trees. So within vegetation, we can have two kind of classes. One is for agriculture land, and one is for the trees. And if you can if you can find some kind of shrubs, so you can also split it into three. So you can have one class as trees, one as shrubs, and one as agriculture land. So among the built up also, you can classify it into some kind of buildings, and again you can further classify it into roads. So now as much as possible you can have more number of classes, but you should train your model perfectly so that there should where we can avoid some kind of error. So let's just start training the data. So first we're going to train the vegetation. So I'm gonna use my false color composite now. So I'm going to change the band combinations to 8 4 3, so that I will get some clarity while training the data. 8 4 and 3. So name it as FCC. Click on the run. So as soon as you create your training data set, so the training has been important as feature collection. So remember, it has 0 elements in each of 4 classes because we not yet trained the data set. So you can open this and stretch it to 100% and click on the apply. Yeah. So wherever you see some kind of dark red color, those are all vegetation. So where you find uh, some kind of gray color, so those are all the built up plants. So you can obviously compare it with the base map. So here you can see these are all the built ups. So whatever you see in the black color is a water body. So let's just start training. So this is a quite a big satellite data set. So start training. So we start with the vegetation. So or else we can have both the false color and as well as the true color in our map, so that we can compare and train it properly. So paste it, change data set to 4 3 and 2. Click on the run. So yeah, now you can clearly see where the vegetation is. So if you want, you can also switch to the false color mode and you can train the data set. So since which one is more useful, you can have it and you can just train it. So let's just start training with the vegetation. So let's zoom in. So add the points wherever you find green color. So this is the training part we are doing for our model, so that the model learns what the vegetation is. So you see all these are vegetation. So this is a water body, don't get confused. And these are all the vegetations. So if you have any kind of confusions, you can just switch to your FCC mode, so that you will get a black color So you'll see in the true color composite there is a green color for the water body, and in the false color composite it's turned into some navy blue or black, so which indicates it's a water body. So don't misclassify the data set. So let's just add a few more vegetation classes. So here you will find some red green colors, so you can always train just clicking on it. So these are all agricultural lands, I think. So yeah, so similarly we can now have my training for the built up class. So simply you come to the urban area, and you can press it anywhere. It's densely urbanized, so that you'll get your training data set. So whatever the white patches you see, those are all buildings. So one more tip is that please try to cover entire your satellite image. So don't just focus on one single side or one part of your training image. So zoom out, scroll down, and place the training data set evenly, and distribute it everywhere, so that your model works good and well. Yeah, I think this much is enough. So next one is the barren land. So here you will see these are all barren lands. Some of the harvested part of the agriculture, I think. So you can just place it as barren land. So in the false color composite, you will see it as a yellow color. So with the bright reflectance of near infrared band, those are all the barren land. Just keep on training your dataset for much better model. So at our last class is water. So I'm gonna switch to the false color mode in order to have clear demarcation of my water body. So here you find my water body is there. So just zoom in and add a points there. So here also you find a water body, add a points there. Small water bodies. So these are all lakes. So Mysore is known for lakes. So there are more number of lakes in here. So that's why we are training it for our model. So these are all water bodies. You can just add the points. Here also you will find one more water body, and this is also water body. Here also you will find water bodies. Yeah, I think that's enough. So we have the training data. So you can just check this and see if our training data is distributed normally. Yeah, it's okay. So we have covering most 80% to 70% of our data set. We have trained the model. So let's just start building with the help of this training data set. So now you see our training data set has been completely imported with the 94 elements of vegetation and 103 elements. That is, this number of training has been provided for the class built up, which is our class 2, and we have this much of training data set 102 elements so for the barren land and 83 for the water. So we have provided the training elements. Now we have to just start the modeling. So create one more variable called training. So whatever our data set is there, we need to merge it down. So we have to make it a feature collection. So with the help of feature collection. So whatever parts are there, vegetation, built up, barren, and water. So use the function dot flatten so that we do not contain feature collections. So inside the feature collections. So you just print the training data set in order to see how does it look. So you have 382 elements with the two columns. So one is the class, which is an integer type, and you have system index, that's a string, so that's not important. You have 382 elements for training your data set. And let's just start building the model. So we create one more variable called training features. So for the image, so remember our input image. So this is the image which we are training with the help of these training samples in order to build a classification model. So from this image we're gonna take the reflectance values with the help of function dot sample regions. So here you will find the function sample regions, what are the inputs required and what are all the arguments required. So it need a collection. So remember we have a feature collection with 382 elements, and we need to specify the property, that is our class. So we have four classes. That's why we have created a property so that it can train and it can get the samples out of these images. And we need to specify the scale. So remember the scale of Sentinel-2 is 10 meter per pixel, and you have the projection and tile scale geometries are all optional. So remember whatever there in the italics are all optional. So there will be given some default to null, null, null. So but if you want to specify, you can specify what are your needs are. So we are gonna sample the region and click control plus space for autofilling the arguments. So we need have the collection that's called training, and you have the properties. So remember the property should be list. The property name is class. So if you have any kind of queries, so what would be a list string, so you can always go to documentation and see the data type here. So you have the collection, it should be a feature collection, and you have the properties. Here you see the property should be a list type. So I'm giving it a list inside a square bracket. So the scale is 10 meters, and the projection tile scale geometries, let's leave it to default. And you can now close the brackets and print this training features. So what this function does is that it took the reflectance values from this image at the points which are given for this training data. So let's just run it. So here you will find the features. Yeah, now you see we have the feature collection with 382 elements. So each of the feature has no geometry, but it has the properties. So here you will find for the first point, it got sampled the values from the image for all the bands starting from B1 to B9, but it's a class 1. For the vegetation, that is the class number 1. So the reflectances from this band is this. So if you can just scroll it down and open some this data set and open the properties, here you will see our class property is 2. The reflectances for the reflectances for the built up, that is our second class. For these bands are this. So the classifier and the training is going to train the model based on these band values and what is the class, and it's going to give a model. So like that, for all the 382 elements which we have created, it has taken the values from all the 11 bands, all the 12 bands, and it has created a training feature. So now you can just create a classifier. So create a variable called classifier. So again go to classifier. So let's see what are all the different classifiers do we have. So you have this number of classifiers for your uh, classification. So you just uh, go to documentation of each and see which one does it suit. So but the most commonly used one are this smile random forest. So this is one of the great classifier algorithm based on the machine learning. So remember this smile, so that indicates it's a machine learning library. So it's using the random forest machine learning algorithm with this number of inputs for training a model. So here you will see the arguments which are required, and let's just train the classifier with the help of this machine learning algorithm called random forest classifier. So you have ee dot classifier dot smile random forest. So remember, you need to specify the number of decision trees in order to decide which class is which. So based on the reflectance values from the training features. So let's just give 500 as the number of trees since the area is too large and you have to train this classifier. So the parameters which required for the classifiers are it's need a feature. So remember we have a training features containing the band values for each of the class. So paste it in here, and you need to specify the class property. So class property should be a string. So the class property name is class, and the input properties is from my image bands. Take all the bands. So just a shortcut to have the band names, or you can specify a list of bands which you want to have it in your input bands for training the dataset. So let's just close this. So you need to open a flower bracket here, so that's why we are getting an error. So now our classifier is ready. So you just print this classifier. So remember this classifier is our model. It has all kind of model elements which you can implement to other region of interest so that you will get your region of interest. So here you will see it's a classifier.train object, and it has the classifier called classifier.smile random forest with the 500 uh, number of training inputs, and it has 12 input properties with all the bands from B1 to B12. So this is our classifier. So this is actual our model which we are going to apply for the images, and we are going to have the classification. So remember, in order to use this classifier, you need to have the 12 elements as the input. So this number of bands should be there, and the classification will work. So let's just create one more variable called classified region of interest 1, because we are classifying our ROI 1, and our image we should specify. So the image which we want to classify is image, and you can press the classify button, and you need to give an input and classifier as an input. So this is our classifier, and your classification is done. So let's just add this to map with the help of map.add layer, and create a beautiful visualization with a minimum value of 1, because we have starting from class number 1, and maximum class we have is 4, and you should give the palette. So palette is the dark green for vegetation, and for build up let's use gray, and for the barren land let's use yellow, and for water let's use blue. And you can have the layer name as classified ROI 1. Click on the run. So layer classified region of interest is loading, and you should get a classified layer now added to the map. So yeah, here you get your beautiful classification done. So it adjusts to whatever the training data we have given. So most of the training data set is useful, where you can see some of the built up areas around the center of the city, some of the green colors, and blue colors are the water, and yellow color is our data set. So yellow color is our built up land. So you can have the visualization some you can have the visualization set with the help of this. So for the built up, let's just use this, and for this one let's just use some green color. So we are making it some look natural, so that it have a beautiful application. So let's just click on apply, so your visualization would look more. Yeah, so black doesn't look so much good, so I can stay with the green, or you can also use red for urban land, because it's destroying the earth. So click on apply. So whatever colors you can choose, you can have it from here, and click on the apply, and then you can click on the import button, so that you will get this visualization parameters imported and use it in your next class. So here you will see my image with parents is imported, so you can have it renamed as LULC, which stands for visualization parameters. So now my for the first region of interest, now my classification of land use land cover is ready. So now I want to apply it for my second region of interest. So let's just add a title. So ROI 2 classification. So this is a good practice in order to avoid the confusions. So let's just create a variable. So you can always import it from your here. So just go and copy from here and paste it down. So you have your pre-image 2, so it should be filtered down to region of interest 2. So you have just have to modify this, and rest or all remains the same. So here your image pre-image should be 2 and image should be 2. And here also you don't need to print this always, you can remove this. So scroll up down, and your training data set is ready. So directly you will come to your classified image, and you will add it to your layers. So you can just remove this, and you will see this. So now I have my input image ready, which I want to classify. So create a directly variable called classifier or classified ROI classified 2, and you have your image 2 which you want to classify. Just click on the function of classify and give this classifier. That's it, the classification is done. Add this to layer with the help of map dot add layer classified 2 with the visualization parameters LLCViz, and rename it as classified layer name classified ROI 2, and zoom down to my region of interest 2 at a zoom level of 16, not 16, 8. Click on the run. So we have missed something here. So let's just print this in order to know we have the image collection or not. So print pre-image 2 in order to know we have the image collection or not, because we are not getting the classification. So yes, we have 6 elements. We have multiplied with the, so let's just see where we have missed. Yeah, we have missed in here. We need to clip to region of interest 2. So let's just run. Now you should get your region of interest. Yeah, Here you will see most of the color is green. So some of it are barren land. So you have some of the water bodies and only a low cover of built up can be seen in here. So without any training, so you have the classification ready. So you have two classification, one at the ROI 1 and another one at the ROI 2. So let's just make it for a third region of interest also. So copy, paste. That's it. Make it ROI 3 classification for your region, for your to avoid confusion. So you have ROI 3. You just rename it as pre-image 3 and make it also pre-image 3. So you don't need to print this. So image 3, you have 3, click to your region of interest 3, classified 3, image 3, map.add layer classified with 3, and classified ROI 3. Zoom to ROI 3. Click run. Now you have three classifications for first region of interest, second region of interest, and third region of interest. So you see we have the classification with the most of the green cover, some of the barren land built up in the center, and you have some kind of water bodies in between them. So I hope guys you have understood how to train a classification model. So with this, with the help of this model, you can apply to any region of interest. But remember, your multiple area region of interest should be somewhat not 1,000 miles away. So if you are building a model for, let's just say, Karnataka or South India, so you can have your region of interest across the South India. But if you train a model in India and you apply, so some you apply that model to some other continent like Saudi or Africa, so it may not work because the reflectances will be different if you move across the globe. So just remember, if you have the multiple region of interest which are more nearer to each other, your model will be so good. So it not like your model will won't work for other continents or other countries, but it will work, but your training must be that much sufficient so that it can have all the kind of training without getting any errors. So here you find our ROI 1, 2, 3. We have built a model for our first region of interest, and we have applied to our both of the region of interest, the other two. So I hope guys you have understood how to do this. So if you have any kind of queries or doubts, you can always post it in the comment section. Thank you for watching.